Hey everyone, this is Kavya from SaltStack. I'm a product manager at Salt Open Team. And today we are kicking off the Salt Office Hours, episode 3. Looking at the agenda for today, one of the questions which we often get is once there is a feature freeze or a bug freeze on a Salt release, what are the next steps? Why does it take time? So today we want to walk through the Salt release process and also the testing process that we follow. Megan and Wayne, who are the Salt core team members, will walk you through that. And then Tom will talk about how from Salt side, we are approaching the Python 2 deprecations. What are the timelines that you can expect and what changes in the product that you can expect as well. These announcements and these discussions should probably take the first 15-20 minutes of your time, and then we'll take questions from the community. So Megan, why don't you go ahead and get started on the Salt release process?
Okay, yeah, so I just asked to kind of go over what our Salt release process looks like and what kind of things in the process slow the release down and where we want to make improvements. So let's go ahead and first talk about the process for a feature or a major release. About a month or two ago, I went ahead and updated our release process documentation that I've posted right there. And that documentation has a lot more steps than what I'm going to go through. Because of time, I don't want to just talk through every step. So please feel free to look through that documentation. I'm just planning on highlighting some of the bigger steps in a release. But there's definitely some more steps. So if you want to check that out, you can definitely check that documentation. So yeah, for a major release, the first thing we have to do is define what our feature freeze date is. And of course, we notify the users in Google Groups. And once we hit that feature freeze, then we branch from develop. And we usually name this branch whatever the code name is for that release, for example, Fluorine. Once we have that branch and we're feature frozen, then we need to make sure Jenkins is running the tests on that branch. And if there's any failing tests, we have to fix those. And then we have to do a manual test run. If there's anything failing there, then we also will need to make sure that we fix those as well. Once all the tests are passing, then we need to convert the branch to the version number. This step can actually be done when we get closer to the release and we know what the version number is. Because we can always rerun Jenkins tests on that new version number and still fix the tests there, but I digress. So then we want to convert the branch to the version number, and the version number is a date number. So in the case of 2019.2, that's the year 2019 and the month of February. As many people have probably seen, we don't always actually release on the date that we specify. And that's something that we definitely want to fix. Then we go ahead, and when we're ready, we want to create a release branch. In the previous release, I actually named this 2019.20.rc1, and that caused a lot of confusion. So in the future, we're just going to name it what will actually be released, which is 2019.20. And so everything that's going to be included in a release in the 2.0 release is going to that branch. If you push anything to 2019.2 after that branch is created, it'll be in the next release, the 2.1. So once we've got this release branch and we say everything's all good and green, then we want to tag, build, and test packages for an RC1. Then we push that out to the community, we notify them. Hopefully lots of community members are testing the RC. And then any issues that are posted during that RC, we want to make sure we go in and fix those. If there's problems found, then we need to do another RC, in this case, RC2. And then we keep going through that until the RC then becomes stable. And then we just simply build and test the release packages. And then once we're going live, we publish the packages, publish the PyPy, and we publish the GitHub release. So if you go to the next slide, Kavya.
Yeah.
All right, cool. So a minor release has a fewer steps, but it is pretty similar in some of the steps. So the first thing we have to do is we need to create a release branch. So for example, the 2019-2.1 release we're working on right now, we've created a 2019-2.1 branch. So anything that's going to go into that release needs to make sure that's in that branch. And anything going still into 2022 will go into the next minor release. Then once again, we have to fix any failing tests in Jenkins and run the manual test run. And then once everything's green, then we want to tag, build, and test the packages for release. And then on the day of release, we publish the packages to repo.saltstack.com, publish to PyPy, and then we also publish the GitHub release. So those are kind of the steps to the release. There's a lot more to it, but that's kind of the higher level view of it. So if you could go to the next slide. All right, perfect. So what are some of the things that are slowing down our releases? Because obviously our releases are very slow to get out. So the number one problem is our testing stability. Every time that we get to the step of needing to fix the test, once we branch, there's a lot of failing tests, and we have to go in and fix all of those. And this step could push back a release a couple of weeks to a couple of months. And so this really is the biggest step that we want to focus on improving. And Wayne is going to be talking about what we're going to be doing to try to improve this step so that, we can try to release more reliably on time. So that is our biggest pain point. The next pain point is manual tests. Obviously, we want to make sure those are automated. About a year or two ago, we made a huge push, and we did end up automating a lot of those manual tests. We had about like 100 to 180, and we ended up getting that list down to about 50. We do have to run those 50 tests on both Python 2 and Python 3. So really that's 100 tests. So we've made a lot of improvement there. A lot of the remaining tests are a lot more difficult to automate. So that process has slowed down there a little bit. But like I said, our main focus is on testing stability at this point. Another thing that slows down the release that we want to improve is there still is some manual release steps. We've been trying to automate steps here and there, but there is some small steps that we definitely can easily automate, like tagging the release is not automated right now, and things like that. So that is one thing we want to improve on. And then another thing that we definitely want to improve on is we want to make the release more transparent. We don't have a really defined path on how to do that yet, but I know that is one of the priorities for the testing work group. So we're hoping to work with them to kind of come up with some ideas. So if anybody wants to join that working group, because we want to make the release a lot more transparent in an automated fashion for everybody to be able to see where we are in a release, especially since it is a slowed down process at this point. But yeah, so I'll send it over to Wayne to talk about testing.
Yeah, thanks, Megan. As Megan mentioned, some of our test infrastructure is a little bit not as stable as we'd like, and that causes a lot of issues. And so we've been doing quite a lot of work recently to really stabilize that test infrastructure and get things sorted. One of the processes that we're underway on is moving to PyTest. PyTest has a lot of advantages over our homegrown test infrastructure. So I think one of the things that it can do as well is run tests in parallel, which should allow us to speed up our test runs quite a bit. That's the other kind of big issue as far as tests go. I'll get to that in a little bit as well. Built-in images, that's another thing that we've done a lot of progress on. Before, we were just kind of building our virtual images for testing kind of on the fly, but now we've got golden images that are set up and are a base image. So when we run our tests, we're starting from a known point, and it's always that same point each time we run the test on the operating system. If you've ever submitted a pull request, then you've probably noticed there are many checks that the pull request requires different operating systems and different Python too, CentOS, Ubuntu, Windows, Mac. And so we've got a lot of tests, or a lot of different operating systems that we need to check to make sure that things work well across the board. So golden images help with that a lot. Another thing that we're working on is getting our test coverage measurement using CodeCov, which will help a lot in identifying where we do need to increase our tests. There are some modules that are a little bit older and haven't had tests, and that can be a source of risk when we're making changes. I'm gonna skip there and talk about a little bit about the new CI tool, like Drone. We've looked into Drone. That's something that our enterprise team uses as well, and we'd like to be able to move to that, or something that's a little bit more reliable and a little bit more secure than Jenkins. I think that would help a lot for just making our test runs again more stable, more reliable. The other thing that we're working on is having our full test suite running on each PR. Right now, it takes a long time to run our test suite, about 4 hours. And so that has to happen for each platform. So typically they can be in parallel, but it still takes 4 hours, which is a very long time. So we're working on reducing that time so that we can run our full test suite each time we have a PR, because that'll allow us to be a lot more stable, a lot more reliable, and it's just a good thing in general. Kavya, you want to go to the next slide?
Sure.
So one of the things that we have done is, and Megan kind of touched on this, one of the issues that we've seen in the past is that when it comes time to cut a release, there are a lot of failing tests on a branch. So what we've decided to do is require all of our tests to be passing before we merge a pull request. In the past, what we had done is if the issue, the failing problem wasn't directly related to the test, we would say, oh, well, we'll go ahead and fix this later, or assume that it's not really a problem. But we've changed that now to where we require all the tests to pass. So that might require us to say, okay, well, we'll put this pull request to the side and then do something else to fix this underlying problem, and then we can merge this in. And that's been really helpful because we've seen a lot of stability and reliability increase already. I know I personally have seen several issues that we've caught earlier just by doing that, making that a requirement. It gives us a lot more faith in the process and that we're doing the right thing. So as I mentioned, we're also working on speeding up the tests. We have a test and release working group that is very committed to these ideas as well, to really improving our tests and getting more transparency in the process. And then some of the issues that we're going to be tackling in the near future here is getting faster, being able to profile and see what tests are slow. I'm actually working on one initiative to do that. One of the things, if you're not familiar with how our test framework works, is most of the tests have a master and a minion, and they make the entire loop as you would if you were running Salt. Now that's a good thing to do, but most of the tests are really just care about this last mile where the minion is actually talking to the underlying operating system. So if we can cut out the rest of this section, that can increase our speed by a substantial amount. One of the test suites that I was looking at went from 50 seconds to under a second. So simply by cutting out all of this network traffic. So that was super promising, and I'm working on getting that merged in. And then we have, I believe it's one more branch that we haven't been able to get green yet. So we're working on getting that last branch green, so we have a nice stable base to start with. And for a lot of these things that we're planning to tackle, next week the whole team is going to be up at headquarters in Utah, and we're going to really just, if you'll excuse the sports metaphor, we're going to do a full court press and just work on stabilizing our release process and making these things much, much more reliable. One of the other things we'd like to have is a nightly or weekly build. As Megan mentioned, our process isn't very automated. And right now there's a lot of manual steps. So if we can automate all of that so we can release nightly, that will make it much easier to release an actual full build when it's time to do that. Plus, for those of you who are interested in kind of the bleeding edge, it also gives you an easier way to keep up to date and testing the latest and greatest stuff that we put out. So that's all I've got about the SALT testing process. Of course, if you have any more questions, feel free to ask those during our QA.
So Tom, next, do you want to take a few minutes to talk through what is the SALT's plan for Python 2 deprecation?
Yeah. Do we have a slide for that?
We don't have a slide for that.
All right, I will shoot from the hip then. So right now, in accordance with the SEP that was merged many months ago, we are deprecating support for Python 2 in the Sodium release. This coincides with the upstream Python project dropping support for Python 2. Now, as we come back, we spent a good deal of time looking at operating system support for Python 2 and Python 3. And even since we did those initial assessments, most operating systems have begun backporting Python 3 to their older operating systems. Most operating systems have actually gone so far as to backport Python 3.6, which has been a good sign. Now, for the Sodium release, we had to decide if we were going to deprecate just Python 2, but then what was going to be our baseline Python 3 instance moving forward. Now, the proposal that I put in was that Sodium stay on Python 3.4 for that release, and that we would then circle back and decide what version of Python to support beyond that. If we come back and we look at upstream Python support, the upstream Python support for 3.4 is over. If I'm not mistaken, I believe it's either also over or will be over at that time for 3.5. But a lot of my thinking around supporting 3.4 still in the Sodium release is that we currently support 3.4, and I wanted to avoid us having a really major jump from dropping Python 2 support all the way up to 3.6. 3.4 still looks a lot like Python 2. And I felt that it would make more sense if our efforts were focused around being able to remove areas of Python 2 support instead of complete modernization of the code base for that release. As many of you are probably aware, complete modernization of the code base from Python 2 to Python 3.6 could potentially involve, well, a lot, especially when it comes to tools like async IO. Now, moving beyond the Sodium release, my plan is to get an SEP out there that describe that so that we can agree on what our ongoing Python deprecation schedule looks like. Now, this is an interesting shift because, of course, for the last almost decade, everyone's just been on Python 2.7 and stuck there. And I shouldn't say decade, but it feels like a decade. That's not an accurate number. It's more like 6 years. But so what we're looking at there is that we need to figure out how to make sure that we've got a reliable schedule for deprecating older versions of Python. As many of you are aware, older versions of Python become, frankly, extremely difficult to maintain compatibility with, primarily because most of the upstream library vendors drop support for those versions. Now, again, one of the interesting things about supporting older versions of Python and where this argument comes from does go back to operating system support of Python, specific Python versions. And so when we come back and we look at operating system support for Python versions, this, again, for a very long time has been the baseline. So, I mean, we go back in time 7 or 8 years, and it was kind of still expected that if you were going to write a piece of Python software, you would be supporting all the way back to Python 2.4 because that was what shipped with Red Hat 5. And I mean, even back then, you know, writing code against Python 2.4 was a pain in the neck compared to being able to use the wonderfulness that had been introduced in Python 2.6 and 2.7. And so because of, or I should say, this old mentality has been recently thrown into question. We've seen a significant, again, number of operating system vendors backporting newer versions of Python and changing in a very fundamental way how Python is being shipped on those operating systems. But this also lends to other things which we've seen inside of the Python community, and that revolves around new ways in which one can ship Python code. So, I mean, there are newer libraries and systems. I believe it's PEP 4.11, which describes the PEX format, just as an example, so that you can bundle your entire Python application into one single, I'm going to air quote, executable, because it's not. It's just an unbundler that unbundles all of the code into a dot directory or a hidden directory somewhere and then executes it. But things like this PEX executable are also still generally based on the shipped version of Python. So one of the other things we're going to be looking at moving forward is what all of our options are around packaging. And so David Murphy here is the one who does most of the work around packaging, and I've been working with him on trying to discover what are the optimal mechanisms that we can look at, especially on older platforms that don't have support for Python 3, or making sure that we've got a model in place so that as we move forward with newer versions of Python, we can make sure that we're shipping the optimal versions and bundlings of those systems. This is one of the challenging aspects of packaging this sort of software, because we want to be able to run Salt on older platforms. But subsequently, that can have an incredible constraint on our ability to introduce new dependencies or even maintain our own stack relative to existing dependencies. As many of you have probably also seen, numerous of the dependencies in Python libraries that are currently in use are also in the act of deprecating Python 2, and many of them are also deprecating Python 3.4 and 3.5. This means that we end up being stuck on older versions of Python libraries on platforms that we need to support older versions of Python. This also goes back into suggestions around being able to bundle all Python libraries on older platforms. And so that in and of itself is an interesting situation, but the net is we're working very hard to make sure the salt is always easily deployable. But some of the things that have been very heartening is the fact that if we go in and we bundle up salt using this PEX system as an example, the resulting application or the resulting salt binary executable is only 12 megs, which frankly isn't that bad considering the overall size of the project. And so that's very good. The other thing that I should mention is that since we have branched for Neon, we no longer need to support Python 2 at all in the develop branch. Unless I'm mistaken, tests have been turned off for Python 2 in the develop branch, which should also assist us moving forward. Literally cuts the number of tests and test coverage that we have to maintain in half. And so that's been a great thing to see. And it's also been a great thing to see the significantly increased stability and functionality up on Python 3. So that we feel very ready to be able to make this move in its entirety, especially for this Sodium release. I think that covers everything. All right, so I'll hand it off to the next person. Thank you, Kavya.
Okay, thanks, Tom. So we'll get started with our question and answer session. We have quite an active discussion taking place in the chat. So for the benefit of those who might just be listening in and not looking at the chat, I'll read out the question and we can get the discussion kicked off. So this question is from Mike Place. Why is the RTT so slow? That shouldn't be. Wayne, do you want to start the discussion that you posted in the chat? Do you want to talk about that?
Yeah, sure. So from my understanding, the reason it's slow isn't so much that the little network part of the traffic, it's everything else in the communication cycle. If we were able to just set up a single client and do 500 tests in one go, it probably wouldn't be nearly as problematic as it is. But instead, what we're doing is making a single request for every single test that we're making. So all of the setup and teardown that it has to do when creating the request and sending that across the wire and then decoding the request when it comes back, all of that happens for all of the tests. And I want to say the number's around 4,000 tests that are doing that. So it's a pretty substantial number of tests that are doing that. And so by sidestepping that, we're able to save a lot of time.
Yeah, one of the other things that was interesting, of course, is that when we considered this as a performance issue, the first thing that we did was profile it, because you don't assume something is a performance issue without profiling it. And so we went in and modified one of the tests so that it wasn't using the remote execution pipeline, but was calling the functions directly. And what was the increase that we saw, Wayne? I mean, it was something like a 60-fold performance increase, right?
Yeah, it went from about 60 seconds for the set of tests to under a second. I mean, it was very substantial.
Yeah, and so at the end of the day, profiles don't lie. That's why you profile.
Okay. I think the next question was network RTT between master minions on the same host should be measured in milliseconds. Is it greater than that?
Probably a continuation from Mike's.
Yeah, that was part of that discussion.
Uh-huh.
Okay.
Okay, so I think the next portion was Did you have any more comments about the master minion approach, or something that we wanted to bring here?
No, I think the next question is Peter Norton's question.
Okay. Okay. The next question from Peter Norton would be, does that 12 MB include or exclude shared libraries like libssl, ZMQ, etc.?
Sorry, does what include shared libraries?
Yeah.
There's a 12 megabyte. Assuming that was something that you were talking about, Tom. The PEX.
Oh, PEX. Okay. Again, I was just illustrating that as one of the plausible options that are available. Now, if you dissect how PEX works, it does include binary compiled libraries, but does not include Python itself. And so what that means is that your SSL libraries are going to be, if you look at a standard Linux build of Python, SSL libraries are dynamically linked from Python. If you look, and so SSL would not be included in a standard PEX build, but the dependency libraries do get included in those standard PEX builds. And so, again, if we end up using this as one of our installation and build options, then that PEX build would include a binary ZRMQ, and it would be built targeted to either a single platform or a set of platforms. And so again, as a reference, if you were to go and build PEX against Python 3.4 on Red Hat 6, the binaries are almost certainly going to run on a Python 3.4 installation on a newer operating system. But again, I haven't thoroughly checked exactly what all of the what the compatibility matrices look like. And frankly, if we go with the PEX option, we're still going to be building on a per OS basis. You want to compile to the optimal way to compile something is towards its relative libc target and its relative runtime targets. Okay. Does that answer your question? I guess I don't have the Q&A open because
Matt is asking, are we sure that covers the same code paths?
I think this is in reference to Wayne's work.
Yeah. For the it covers the same code paths once it's hit the execution modules or the states. At that point on, it does cover the same code paths. It's just all of the network and setup and all that it is skipped out, which I think is a good thing.
Wayne,
Okay.
This still covers the communication between the master and the minion, or is it not? Is it just doing the minion part?
So what we're looking at is that the tests in their current state are executing across the communication bus just way more. Instead of testing that bus, 15 times to test different ways in which that bus can be exercised, it's just running the same thing over the bus over 4,000 times. And so when we look at the modifications that we're putting in, we are still testing that bus very, very thoroughly. We just aren't testing it very thoroughly 1,000 times more often than we need to. Okay, more like 350 times more often than we need to. But yes, this change that we're looking at does not lower our actual code or situation coverage.
Yeah, absolutely.
And then a number of the tests that we have will still be using the remote execution bus because we have a number of tests that are specifically designed not only to test the execution module that they're reaching out to, but the behavior of the execution module relative to its invocation when called through the remote execution system. All of those tests are being preserved in place.
Yes. Yeah, absolutely. Well said.
So the next question, Peter Norton revised his question, and so he's asking, I was wondering how hermetically sealed you were thinking about the problem. Salt allows for a lot of runtime loading of the modules via Dender Virtual, and I was wondering if the distribution method affects how much of that you own.
Oh, thanks. So again, we're not solid on using PECs. There are a lot of different options about how we can go about doing this. Now, and this is definitely one of those considerations. When we come back and we look at the different options that we have for deploying Salt, one of the primary questions that we have is what Python runtime it's going to be associated with. When we come back and we look at the execution of Salt, there are a huge number of optional dependencies. And traditionally, those optional dependencies have been installed in your Python path. And so this is still one of those questions that we're struggling with, and we'd be very open to feedback on. We've got quite a few customers and users who have come back and said that they would like to see just everything in one package. But one of the things that I want to emphasize is that if you build a PEC system and you execute it with your runtime Python, then the PEC's runtime has access to all of your installed libraries. If you build a PEC system and run it with an isolated Python runtime, then it does not have access to your installed libraries. And so this just becomes a question of what types of deployments we want to be able to support and what that looks like. And so it would make sense to have a hermetically sealed option where we would say that we're going to ship an all-in-one. This includes Python and the whole kit and caboodle. And then also be able to execute the same without that. And frankly, that would be a really easy thing to do. If again, using PECs as an example, if we have a PECs executable, and you execute that PECs executable using, you can execute it using an arbitrary version of Python that you have installed. The version of Python that you have installed will therefore dictate which Python paths it's going to load into the system. Does that answer your question? Okay, I'll take sure, thanks.
Okay. We'll probably give a minute for the questions to come in. Austin has a question. He's asking, is work underway now to move to async.io? Roughly when might that be available?
I would love to move to async.io for many reasons. Many reasons. So let's see. One of the tricks that we have about moving to async.io is that involves a fairly wholesale, large-scale change to the code base. And so that is something that I wanted to see happen for the Magnesium release. So we've got two major, the Magnesium release and perhaps the one after it. Now the reasoning for this is, again, going back to the Sodium release, I'm much more concerned with spending our time and resources making sure that we have packaging ready for Sodium and that we have cleanly deprecated Python 2, as opposed to some of the heavy lifting that we're looking at there. The other thing is that we don't want to do the version of Python rug pulling too quickly. when we move to full async IO, I want to make sure that we're baselining at least on Python 3.6. I mean, what you get with some of the async IO features in 3.6, particularly async generators, is kind of amazing. I don't know if you've taken a look at this, but oh man, like you can implement a full pub sub and 3 lines of async IO using async generators. I mean, obviously you would put more checks in there, don't get me wrong, but I'm just saying it's pretty slick stuff. But yeah, I mean, that is going to be a pretty significant effort. That is going to involve a complete migration away from the use of Tornado, something that I would be, frankly, pretty darn thrilled to see. And yeah.
It is probably just worth noting that under the hood on the newer versions of Tornado, it is using async IO when it's running on a newer Python. And then one of the other things is just doing async IO is one thing. Moving to like async and await keywords is another thing, because we lose support for certain Python versions.
Right, and that's another one of those reasons why I don't want to make that full dive, right? Until we make sure that that we have made official deprecations of all Python versions which no longer support full async IO syntax. But so yes, we do want to move to async IO, but like Daniel is saying, the upshot is that the migration over to newer Tornado allows us to support and have a compatible loops, and that beyond that, we want to make sure that our syntax is in line with our current supported versions of Python. Okay, any plans to create an automated build release working group? And how much of the current tooling is publicly visible? So we do currently have the testing and release working group, and so I mean that's happening. And sorry, Dave Murphy, looks like you wanted to mention on the tooling and publicness of it.
The automated tooling to build on both Python 2 and Python 3 are open sourced on GitHub, SaltStack and SaltStack-Py3. I'd be more than happy to take contributions.
Yep, it's all out there.
Has been for years.
So it is cool, and please check it out.
We can post the links up after this conversation.
Okay. You're welcome, Nick. It's always one of those interesting, awkward moments, right? I feel like I have to fill in the dead space as we wait for another question to come in. We don't know if anyone's typing. Zoom doesn't say if someone's typing.
Oh, that's right. It was interesting watching the PSL presenters on Main Street in Park City during the Winter Olympics as they try to fill in space and time.
So we just got a very, very critical question that needs to be answered. And the answer for that is that here in Lehi, Utah, the sky is perfectly blue. The weather is fantastic. It's finally warmed up here. I mean, we had an incredibly long winter, which is weird. Usually it starts getting hot here sooner. But it's finally up at the 80s, which is where, we're close to where it should be for July. This time of year should be, around 95 to 105. And I need my heat. Just as much as I need my snow in November.
You can always come visit us in Arkansas. We've got plenty of heat here.
So the fires haven't started yet? Yeah, so we're in Utah. Actually, we did get some wildfires last year, but no, we've been okay. any day now, we'll get some wildfires because we had such a wet spring. Okay, if the questions have devolved to the weather and wildfires,
Yeah.
I think we might be okay on wrapping up. Unless there
Sounds good. Okay, sounds good. Thank you all. And the video will be uploaded on YouTube, so I'll share the link on the Slack community channel if someone has missed a certain portion of it or if you want to view it again. Thank you.
And I will Slack you the links on GitHub to the open source build utilities that we use, framework.
Thank you.
Okay, thanks.